Hey guys, let's dive in here. We're going to continue with substitution today. Some of us are still struggling with these concepts. I think there's three pieces of it, and we're going to look at all three. Number one, we're going to look at solving for a variable. And then number two, practice some more of the substitution actual concept and doing it. And then number three, we'll just practice some good old solving of equations so we can make sure we can connect all the dots. Do it. All right. Solving for a variable. Let's be clear on what that means, review that a little more. What does it mean for an equation to be solved for a variable? If we have an equation that's written like this, x equals, and everything else is on the other side, like you might have 3y minus 7, let's just say. This is an equation that's solved for x, okay? We would say this equation is solved for x. If we have an equation written as something like this, it's the exact same idea, just with a different variable. We would say that this is an equation solved for y. Now, the reason why I would say that is because the y is by itself, and everything else is on the other side. So we're saying with that in terms of that first equation for x is equal to the expression 3y minus 7. So whatever x equals, the 3y minus 7 also equals that same amount. So those are interchangeable. I could go into another equation if that was part of a system of equations, take out the x, and put in the 3y minus 7. On that second example, if y equals 11 minus x, this is exactly the same as the value for the y. I could go find a y in the other equation if this is a system of equations, pull out the y and plug in 11 minus x because I know what the 11 equals. And the whole premise of this, guys, is the equal sign. Y is said to equal that other value, or x is said to equal that other value. That's why it's solved for x or y. Now, if we have something like this, that one is not solved for x or y. Okay, because they're not by themselves. If you want to talk in terms of being solved for, this equation is solved for the constant, which isn't something we ever do in math. It's not a thing it's not useful to us. It's not a type of expression or goal we would have. So since it's not solved for x or y, it's not solved for anything that's useful, this is actually called standard form. You usually need to take standard form and rewrite it into some other form to be able to use it for things. So go ahead and look at these 6 problems on the right. You've got A through F. Some of those are solved for a variable, some of them are not. First thing I want you to do is just identify. Look through those right now, write them down, or rather than write them all down, just write down the letters of which of those equations are solved for a variable. Okay? Take like 10 seconds. This should be pretty easy. Which of those are solved for x or solved for y? Okay. Hopefully, that's really easy for you to do. We would look through here and we'd say, well, the first equation, it's solved for y. So there we go, that one. Solved for y, y's by itself. Keep looking. B does not have anything solved for a variable. We're gonna have to rewrite that in a minute. C, oh, there's another one solved for a variable. C is solved for x because x is by itself. D, not solved for a variable. E, not solved for a variable. F, not solved for a variable. So only A and C come to us solved for a variable. The other ones we'll have to rewrite. So let's go ahead and do that right now. I'll do an example. I want you to work on those, so I'll give you an example real quick. If I've got that, to solve for a variable, you are allowed to pick Do I want to solve it for y to get the y by itself, or excuse me, the x, or do I want to solve it for y? Okay, you can pick either one. You're allowed to do it either way. Mathematically, it's possible to do either way, but hopefully you're going to see right now as you're looking, the y looks way easier. The reason why the y is easier is there's no coefficient. The x has a 3 in front of it, so there's an extra step to solve for x because you would have to divide the 3 off to get that x by itself. The y only requires that you get rid of the other term. And we'll have to deal with that negative in a second, but that's easy enough to do. So if I'm going to get the y by itself, I want to solve the equation for y. That's what I want in a minute. Then this is what I need to get rid of. I got to get rid of that 3x to get the y by itself. I need to move the 3x over to that side. Okay, and hopefully this is looking familiar. This is something we've done before. Let's clean things up a little bit. It's getting kind of messy. So we're back here and we want to get rid of that 3x. And it's the whole term we're going to cancel, so we're going to subtract it. I'm not trying to solve an equation for x. I'm trying to get rid of the whole x term. So if I have 3 x's and I take away 3 x's, they all disappear. And I do the same thing on the other side of the equation. I do a negative 3x on both sides so it stays balanced. And again, that shortcut, which I'm beginning to introduce to you guys, is if I want to cancel a 3x off the left, I can just put a negative 3x on the right. That's the result of doing the cancellation. Once you get that, feel free to just put the negative 3x term on the other side. And now, in that one step, we're really close to solve for y. We just have to deal with that negative. Okay? And that's easy enough. If you flip the sign of that variable, once you're solved for that variable, just make sure you flip the sign of everybody else. So that positive 11 becomes negative. The minus 3x becomes positive 3x. And there we go. Solve for y, and we're done. All it takes is moving over the variable, and then if you happen to have a negative, flip those signs. Now, let me just do that in quick motion without talking to show you guys. If I want to solve for x, it's as simple as this. He moves over and becomes negative. And then I just flip the signs of each of the other terms. And in about 4 seconds, I'm solved for x. That's all it takes. There's those examples for you. Why don't you take a minute to rewrite b and solve for the variable, d, and e. F takes a little more work. We'll look at F in a minute, but take a minute, pause the video, and do B, D, E. Solve those for the variable, and then come back and see if you're right. Okay, let's check and see. I'm going to move that 5x over. If it's a positive 5x, he becomes a negative 5x on the other side when I cancel him. So he's gone. Now I've got it solved for negative y. I'm going to flip the sign of that y, which just means flip the sign of everything else as well, the other 2 terms. And there we go. My equation is solved for y. D is even easier. Minus 5y will become plus 5y. And again, it's because to cancel it, you can just add a 5y. That goes away. And now I've got x equals 4 plus 5y, simple as that. We're solved for x. E, that 11 is going to be subtracted off, so it's going to move across, become a negative 11. I'm going to rewrite that because it's kind of messy. Now, the 9x that was there is positive, so we need a plus there. We need to separate those terms and make the invisible plus in front of the 9x visible, so we have a way to separate them. Now notice that y still has a negative sign, so go through and change those signs to finish rewriting it. So now it's really 11 minus 9x equals y. And there's E, solved for the variable. Okay? Now notice, hopefully you guys already saw that before I pointed it out. The y was by itself. That was the easy one to pick. The x was by itself without a coefficient. That's why we picked that. And the y was by itself, okay? Those are easier to pick than a variable that has a coefficient. Now let's look at f, because that's the one that still has a coefficient on both variables. Same idea, just one extra step. Okay, if I'm going to solve that variable, same idea. If we're going to pick the x, you can pick either one, but we'll pick the x. That'll give us no fractions at the end. So in a minute, we should have x equals and everything on the other side. So I'm going to cancel off that. I put two x's into f. My apology, I just noticed it. That should be a y. Okay. There we go. To move that over, that minus is 6y. It's just going to become plus 6y on the other side. That's going to cancel out. And right now I'm almost done. Instead of 3x, I need to have just x. And this is where we use our solving skills. Think of the 3x as 3 variables of x. They're all on the left. We want to shrink or scale down from 3 to 1. How do we do that? The same as we always do when we're solving an equation. We have to use division to divide from 3x's down to 1. And the key is make sure to do that on both the other sides. This is really just like the fraction buster concept. It's not any harder, but just wanted to make sure we've got the other concepts first before we do too much of this right now. But really, hopefully that looks just as easy as the other solving term to you guys, the other solving type. There you go. Solve for x. Simple as that. Now, let's apply with some substitution. Okay? Use substitution to create an equation with only one variable. Okay? So our goal here is to rewrite from a 2-variable equation to 1. This is exactly what we've done in class the last couple days. And if you need to, you're going to have to solve for a variable first. Okay? So step 1, just like we talked about in class. If you need to, solve an equation for a variable. And then number 2, substitute that in. You may not need to do step 1. It may already be solved for a variable. That's for you to choose. So look at each set of problems, and if you've already got something solved for a variable, you just need to substitute. If you don't, solve for that extra y, and then substitute. All right? Go ahead and do number 1, and then come back, and we'll do one at a time so you keep getting the feedback. Okay? Do number 1, and then unpause. Go. Okay. First one there, we've already got solved for y, so that's what we're going to substitute. So we're just going to plug that in. I'm going to plug it in right there for the y in the other equation. Now there's a 2 multiplying with the y, a negative 2, so we need to rewrite it so that distributing still occurs. Okay, instead of negative 2 times y, it's going to be negative 2 times what we substitute. So we'll throw in parentheses, and we're substituting in because we see up here at the top that y equals 5x plus 20. And then just finish writing it equals negative 19. There you go. Number 2. Pause it and do number 2. Go. Okay, let's see. Okay, can't move those. I guess we'll leave them. All right. I'm looking at the 2 equations in the bottom equation. The x and the y both have a coefficient, which means it's not an easy rewrite to solve for the variable. Up on the top, the x has a coefficient, but the y doesn't. So hopefully that's the easy choice, okay? Pick that y. How are we going to do that? Well, move the 3x across by making it a negative 3x. And now we're really, really close to solve for y. Just flip the signs. Since right now we're solved for negative, we'll make that positive 20, and we'll make it positive 3x. And in that one simple step, we've got an equation solved for y, and there's what we're going to substitute. So go to your other equation and substitute in that value for the y. 5 times what y is. 20 plus 3x. And then just finish the rest. Equals negative 4x plus 26. There you go. Now we've got an equation in one variable that we can solve for x. Pause it, do number 3. All right, let's see. Again, if I look at the first equation, those are both coefficients, so that's not going to be an easy rewrite to solve for the variable. Or even if it is easy, I shouldn't say it's not easy. It is easy, but you'll likely end up with fractions. Looking down here, that one's got the coefficient, but x by itself, that's super easy pickings. Let's go for that. So we just got to move that term across. The negative 4y becomes positive 4y. Okay, and remember, it's just because of this. That's not a division. Those would cancel. The minus 4y and plus 4y cancel. That's why we can do that. So we've got x equals 20 plus 4y. And right here is what we can substitute with x in the top equation. Right there. So if we rewrite it, we've got 2. And then take that x out, and we're going to replace it with the 20 plus 4y. And finish that equation. Minus 3y equals 15. And we now have an equation solved for just one variable. Okay. I'm hoping this stuff is starting to click for you. Now at this point, we're going to practice our equation solving skills to make sure we're not rusty there. So we're just going to finish these 3 problems. We're going to go right back to number 1. Give ourselves some space. And we'll just finish. So notice on equation 1, we had it solved for y. We substituted that into the other equation. And now we've got this equation in one variable x. So now let's just finish and practice our solving skills. Pause it. You guys need to be distributing. Then after you distribute, you'll combine those like term x's, and then you'll have a 2-step equation to solve. Okay, go ahead and get to that point. Once you solve for x, you can go back into either original equation, plug in for y, and solve that. Go ahead and pause, go as far as you can, and I'll pick it up and work with you in a minute. Go. All right, we're back. So I'm going to leave that 3x. I haven't used it yet. And I'm going to distribute the negative 2 times 5x. That's negative 10x. Negative 2 times the 20 is negative 40. And it all equals negative 19. And just keep going. 3x and negative 10, that's negative 7x. And just keep working. We always come back to that 2-step. I'm going to add over the 40. That's a positive 40 and a negative 19. Good guy, bad guy. So we're going to end up with 21, positive 21. Let me see that our x equals negative 3. Okay, now if you're here, we just need to plug that into either of the 2 original equations. Okay, this guy or this guy, either one, whichever one looks easier. Now because the top equation was already solved for y, that's just going to be easier and less work. You just plug in the x on the right side, do the calculation, and it tells you what y equals. So I'm going to use that. So I'm going to write down that y equals 5x plus 20. I'm just going to rewrite him down here. Y equals 5x plus 20. That's one of my original equations. And I'm just going to plug in to solve. So really, we're just using the substitution method again. We're just replacing the x with the value we have. Negative 15 plus 20, which is 5. So the y equals 5. There you go. So put them together, our final answer, we found out the x was negative 3 and the y was 5. Okay, you just solved that system with substitution. Now do it again. Okay, do it for problem number 2. I'm going to erase some of this to give you some room. Problem number 2, we've got this equation solved in one variable, so go ahead and solve that guy for x, and then plug him into one of the 2 originals. And by the way, you're free to plug in right here. When you rewrite the equation to solve it for y, that's the easiest place to plug in the x right here. It makes it super easy to finish and find y. That's where I'm going to plug in a minute. Go ahead and finish and see if you can do it. Okay, let's finish and solve this. You've got distributing, so 5 times 20, that's 100. 5 times the 3, 15x. If at any point you see that what I'm doing is different from you and you made a mistake, pause it, fix your mistake, and then work back through to a correct solution. Because from here on out, if you miss something, everything else will be wrong. So fix everything from here on out and unpause and continue with me. Okay, now I've got variables on both sides. And this is going to use the exact same concept as we've been using when we solve for a variable. If I don't want the minus 4y on the left, I want it on the right-hand side. You're just doing that plus 4y to cancel it, and it becomes a plus 4y over here. That's the exact same concept we're going to do with our normal solving now, okay? The minus 4x, I want to move it over to the left. So I'll do a plus 4x to get all those x's to this side. Now I've got 19x on the left. If I want to save time, I can then move all my constants over to the right. So I'm going to cancel off that 100 at the same time and move him to the other side. So we've got 26, or 100 minus 26, because there's 100 bad guys, 26 good guys. So that would be 74, and it'll be negative, more bad guys. I don't know how many times 19 goes into 74, but I think I did some math wrong somewhere. Okay guys, found my mistake. When I was writing these problems up, when I created the set for this assignment, that 26 is supposed to be a 24. Okay, so right here, that should be a 24, my mistake. And when we do 24 in the negative 100, that's actually going to give us 76, which is the correct thing we want to see here. Because negative 76 does work out to a whole number. My apology. Flex with it and roll. If you're at this point, good job. Okay, if we divide off the 19. Now, let me show you a shortcut for this. I think of it in terms of 20 and then going into 80. Because I know 20 goes into 80 4 times. That's super easy. And if 76 is 4 units less than 80, then 4 19s is going to make 76. So I know easily in my head that that'll be negative 4. Now, I'm not quite finished yet. I'm going to use this equation up at the top, okay? The one that solved for y from my original 2. That's the easiest way to go. Y equals 20 plus 3x. So I'll just plug him in right there. That makes the work really simple. So it's going to be 3 times a negative 4, and just fill in the rest. So I end up with 20, 20 minus 12 equals 8. So there you go, y equals 8. And there's the second one solved. I'm hoping you would have got that right if I hadn't messed it up for you. Sorry about that. Okay, there's number 2. Let's practice number 3. Clean this up a little bit so you've got some room to work. All right, so number 3, there's your equation up top, right? This one up top is the one rewritten in a single variable. So you want to go ahead and solve this equation and then plug in to finish your system. All right, go. Okay, Let's dive in. I've got some distributing followed by some like terms. So we got 40, and then 2 times 4 plus 8y minus 3y, so that's a 5y. So the two-step we arrive at is 40 plus 5y equals 15, and now we do what we always do, okay? I'm minusing off the 40, because remember, in terms of what comes first, what comes second, the variable is always what we're targeting. I'm trying to get to that. So kill off the constant first. That's the first thing we target. Then kill off the coefficient next to the variable second. So I'll minus off that 40. 15 minus 40, negative 25. We got that 5y. So we can divide off the 5's on both sides, and we see that y equals negative 5. Okay, now we've got our variable y. Right here is the equation we just rewrote for problem 3. And again, notice I'm going to use this one, the rewritten one that we got solved for x, because that's the one with the least amount of work. You could use the original equation here or the original equation here. You can use either of those. But it's going to be less work to go to the equation solve for x. So I'm going to plug in there. So I've got x equals 20 plus 4 times, and what did we find y equals? It's negative 5. So there you go. We have 20 minus 20, well, that equals 0. And that's a valid answer. So x equals 0. So the solution for the system, x 0, y of negative 5. And there you go. All right, guys, I'm hoping that these dots are starting to connect.